Okay, we've got a slightly different question. It's question 7 from the textbook, page 94, exercise 6c. We've got a random variable with n is 50 and p is 0.4, and we're asked to find something different. We're asked to find the largest value of k so that the probability that x is less than or equal to k is smaller than 0.05. This is not one that you can do on the calculator. What we need to do here is turn to page 204 of the textbook and look up the tables. The tables there are the numbers that you would generate on the calculator for the given values. So let me bring up a copy of the table, the relevant table here, the one for n equals 50. This is the table. It shows all the probabilities, and you can use this to work it out. It shows all the probabilities given a different value of p. So, for example, if I take this number here, this is the probability of getting exact 8 or fewer successes if the probability is 0.25. Okay, that's showing you that. If what we want is the column where it's 0.40, because that's what the probability is in our question. It asks us to go down the list and find the smallest number, the largest value of k, so the largest number down here, where the probability in this column is smaller than 0.05. Okay, so let's just delete a few of those. Let's go through. We're going to go down this column, searching out, looking for where the probability is below 0.05. So all of these values are obviously very small, and then we get to here and you can see that there's the changeover point where it goes from 0.028 to 0.054, and that is the smallest one that's lower than 0.05. The next one's above. So reading across, we can see that the value there is 13. That means that k, the number that we're looking for, is 13. The way we would choose to write that and to illustrate the answer is we would say, for A, that the probability that x is less than or equal to 13 is equal to 0.028. That's the number we read off the table. And for B, and also at the same time, the probability that x is less than or equal to 14 is 0.0540. Therefore, our k value is 13. That's what we do. We illustrate from the tables what the values that we found were and write it out. Okay, part B. In part B, this time we're looking for the probability that x is greater than k. Now, before we can do that, we know that the tables are only looking at less thans. So I need, in part B, to start doing some work. The probability that x is more than k is equal to 1 minus the probability that x is smaller than k. Okay, smaller than or equal to, because that's what the tables look up, and that's what we need to remember. We remember that the tables and also our calculator do less than or equal to k. Let me just explain that quickly on a number line. We said that if we have the number line there, going all the possible values, 0, 1, 2, miss out a few, then I've got k minus 1, k plus 1 there, carrying on, then it goes 49, 50. If we're looking for all of the values which are strictly bigger than k, that would be this bit. Strictly bigger than k would be all of those up there. So it's 1 minus all the values that are k or less. Now, it's worth doing this kind of number line calculation when you're faced with one of these questions. It literally is worth looking at doing that. Okay, so that means that 1 minus the probability that x is less than or equal to k, must be smaller than 0.01. just rearrange that quickly and we see that probability of x being less than or equal to k must be greater than 0.99. Okay, if you don't recognize how to do this, that is a key fact. What we've done here is I have subtracted p, the probability from both sides. So if I look at the extra steps, if I just do it over here quickly, that I'm going to say that 1 is less than 0.01 plus the probability that x is less than or equal to k. That's easily legible there, yeah, okay. Take away the 0.01, I get 0.99 is less than the probability that x is less than or equal to k. Reversing that gets me back to that. Well, by reversing, I mean switching the sides round, okay? But you should be able to do that straightforwardly. I'm going to bring in the table and we'll be looking for the first value where the probability gets bigger than 0.99. So here's that same table again. We've got n is equal to 50. So this is the correct one. And we want to look where the probability is 0.4. So just need to whiz down this table and find the value where this is bigger than 0.99, and the first one is here. Okay, I've got 0.984 for k is 27 and 0.9924 for k is 28. So which value do I choose? I want the smaller of the two because I want one where it's less than that. So those are what we're going to do. I'm going to write that out again so that we can just see the workings. So from the tables, we saw that the probability that x was less than or equal to 27 was equal to 0.984, and the probability that x was less than or equal to 28 was equal to 0.9924 from the tables. Therefore, k equals 27 because that's the first one where the remainder would be smaller than 0.01. You need to be able to work those through. There's 2 more examples that I'm going to work through. Hopefully this one helps you.